So, good afternoon, students. So, myself, Sushma. I've done BE in Oxford College of Engineering. So, today I'm here to teach you all physics. So, my teaching methodology will be like first we will go with the assignment questions, and then we'll come back to the concepts. So, I'll be like merging both. So, first assignment question, then concept, assignment question, and concept. So, this is the way we'll be moving. Okay. So, yes. So, first we'll be seeing the first question. So I'll read you the question first. Determine two unit vectors perpendicular to both A vector, okay, and B vector is this, okay. So now, what is a unit vector? Is nothing but a vector which has a value equal to 1, okay. So now we will see the solution for this. So I hope you understood the question. I'll read it again. Determine two unit vectors perpendicular to both A vector, which is I cap minus 2j cap plus 3k cap, and B vector is equal to 2i plus 4j. Okay. So now we'll see the solution for this. Yes. So these are the two vectors that have been given to us, right? So how will we write this in the form of a matrix? So we'll write I, j cap and k cap, okay? So now we will write the values for this. So I cap is 1, okay? And minus 2 j cap, and we have 3 k cap. And B vector is 2 I cap, 4 j cap, and k cap is not given. So we will consider here it as 0. Okay. So now how will we do the matrix multiplication? Suppose if we are doing for the I cap, then how we will do is, so this is the I cap, matrix, right? So we will be crossing this line. Okay. So we will consider only this part, j cap and k cap. Okay. And we will do the cross multiplication. So minus 2 into 0 is 0, and 3 into 4 is 12. So we got 12 I cap. Okay. Then moving on to j cap. So minus into plus here would be minus. So here we have taken it as minus. Okay. So when we are doing for the j cap, so you need to cross the j cap line. That is, in j cap we have minus 2 and 4, right? So we will be crossing this line. So we will be considering now I cap and k cap. Okay. So same way we will be doing the cross multiplication. So 1 into 0 is 0, and 2 into 3 is 6. So we have got minus 6 j cap, right? And now we will do the same for the k. Okay. So k cap, what we have here, 3 and 0, right? Yeah. So now we will be crossing this line. So we will consider now only I and j cap. Okay. So again, do the cross multiplication. So 1 into 4 is 4. 2 into minus 2 is minus 4. So minus of minus 4 will be plus 4. So 4 plus 4 is 8k. Okay. So now when we take 2 as common, okay. So we will have 6i cap minus 3j cap plus 4k cap. Okay. So this is the equation we have got. So but what is the the formula for this? That is A vector cross B vector divided by the modulus of A cross B. So how would we calculate the modulus of this A vector and B vector? So we will be taking these values. That is modulus of x square plus y square plus z square. So here if we take I square plus j cap square plus k cap square. So here it would be 6 square is 36, 3 square is 9, 4 square is 16. So we will get this answer as square root of 61. So there is the modulus. So how will we write this? So how will we write the answer? So that is, here we have 2 into 6 I cap minus 3 j cap plus 4 k cap. So this we will write as it is divided by the modulus value that we have got. So this would be your final answer. Okay. I hope you have understood. So first step, we will write whatever the given vector, we will write it in a matrix form. Okay. So how do you write it in a matrix form? The row wise. So here it is given as row wise. So here also you will write it in a row wise. B vector also same, 2, 4, and since k is not given, you will take it as 0, right? And then you will calculate for individual vector. So I cap you will calculate separately, for j cap separate, and for k cap separate, and then you will get an equation. So once you get an equation, the next thing is the next step is you need to calculate the magnitude. So how will you calculate magnitude? Suppose let us take this as x, y, z. Okay, so it is like x square plus y square plus z square. That will give you the magnitude, square root of x square plus y square plus z square, right? So what is 6 square? It is 36. 3 square is 9. 4 square is 16. So we have got root of 61. So apply in the formula. So you will just write this equation divided by the magnitude, right? So this would be your final answer. Yes, I hope you all have understood this assignment question, right? Yes. So now we will see one concept. Okay. Yes. So today we will be, looking into the most interesting chapter, which is vector algebra. Okay. So we will move on to the first concept. So yes, first we will see about the first concept, which is scalars and vectors. Okay. So what is a scalar? Yes. So scalar quantity will remain invariant. So what do you mean by invariant? It is nothing but it will remain unchanged. Okay. So irrespective of any transformation of the coordinate systems, if there is any changes in the coordinate systems, then also it will remain unchanged. Okay. That is said to be a scalar quantity. Okay. Okay. So what is a scalar quantity? It will remain invariant. Invariant, which means it remains unchanged. Okay. Invariant means it remains unchanged. It will not change. So when it will not change, if there is any transformation of the coordinate systems. So irrespective of the transformation that is happening in the coordinate systems, that will remain unchanged. Okay. So that is the scalar quantity. So scalar is a physical quantity that can be described by a number. Okay. So the scalar quantity, we will describe it by a number followed by unit of measurement. Okay. So this is how we will be representing the scalar quantity. Okay. So it is a physical quantity where we will describe it by a number and also by the followed by unit of measurement. Okay. So how will we represent exactly the scalar quantity? Yes. So the scalar quantity can be represented in a diagram. Okay. Equation, letter or a symbol. Okay. So in this way we can represent the scalar quantity. Okay. So I repeat, scalar, we have seen 3 points under this. So scalar quantity will remain invariant. Okay. Which is very important. So when it will remain unchanged, if there is any transformation, irrespective of the transformation of the coordinate systems, it will remain unchanged. Okay. And scalar is a physical quantity. Okay. That can be described by a number followed by the unit which you are measuring. Okay. And the third thing, how can you represent a scalar quantity exactly? That is in the form of diagram, equation, letter or a symbol. Okay. So we have some of the examples here for a scalar quantity. Okay. So here they have given a very important point. A scalar quantity has magnitude only. Okay. So this is the main difference between scalar and vector. So in scalar, you will have only the magnitude. But in vector, you will have the magnitude and direction. Okay. So suppose a car. So how will you measure the, at which how fast the car is going? So you will measure it with the speed, right? Yes. So this is a scalar quantity. And how about time? You will measure in seconds, hours. Yes. Yeah. So that is the scalar quantity. You will have only the magnitude but not direction. Clear? Yes. Yes. For example, here we can represent the mass of an object by the letter m. Okay. Where m would be the number with a unit. So how will you calculate? Suppose if I give you an object, some object, for example, you can take. Okay. So how will you calculate the mass of that object? By the letter m. Okay. Where m would be a number. So suppose if I give you 10 apples and I'll ask you what is the weight of it, what is the mass of it, right? So you will say it is suppose so and so kg. Okay. So how would you calculate? Based on the weight, right? So that is a number followed by the unit. Exact. This is an exact example of a scalar quantity, which is 60 kg. Okay. There is a number followed by the unit of measurement. So scalar quantities can be added, subtracted, multiplied, and divided like ordinary numbers. Okay. So like how you add the normal numbers like 1 plus 2, 2 plus 3. So in the same way, you can add the scalar quantities also. You can add, you can subtract, multiply, and divide. Okay. So same operations how you perform on the ordinary numbers. So same way you can do it for the scalar quantity. So all the rules of the arithmetic operations will apply to the values of the scalar quantity. Okay. As I said, you can do all the arithmetic operations like you do for the ordinary numbers. So same way you can do it for the scalar quantities also. So scalar quantity have an important property. So what is that property? A scalar is a quantity whose value will not depend on the coordinate system, right? So what is the question here? The A vector is this equation and B vector is this equation, right? So how will we do A cross B vector, A vector cross B vector? Again, we will write the equations in the form of a matrix, right? So 1 I cap, so here we have written 1, okay, minus 7 j cap, so here we have written minus 7 plus 7 k cap, right? And B is 3 I cap minus 2 j cap plus 2 k cap, right? So as I said, first we will be crossing this I part and we will be only considering j cap and k cap and we will cross multiply. Okay. So I cap of minus 7 into 2 is minus 14 plus minus of minus 14 would be plus 14, right? So minus 14 plus 14. This term will tend to 0, right? Yes. And minus j cap of, so we will not consider j cap now. We will consider only the I cap and k cap, right? So 1 into 2 is 2 minus 7 into 3 is minus 21. That is minus 19 j cap. So minus of minus would be plus. So it is plus 19 j cap, right? So that would be 19 j cap plus 19 k cap. So 19 into j cap plus k cap. Okay. So this is the result we have got. So there is the step 1. As we have seen in the last assignment question, this is the step 1, right? So what is the next step? That we need to calculate the magnitude. Okay. We will calculate the magnitude. So magnitude 19 of j cap plus k cap, right? So since 19 is common for both, we will write it as 19 to the square root of 2. Okay. So what do you mean by saying that the two unit vectors are said to be perpendicular? Yes, this is the formula. Okay, this is the formula to check whether the two unit vectors are perpendicular or not. Okay, so A vector cross B vector, we have got it as 19 into j cap plus k cap, right? This one. And the magnitude, we have got it as 19 to the square root of 2. Okay. So 19 and 19 will get cancelled. So the final answer is j cap plus k cap divided by the square root of 2. Okay. So this is the simple problem as we have seen the last problem. So I have just given an example. Okay. So to make you better understand, I've just given you an example. So it is the same question. Okay. Determine two unit vectors perpendicular to both. So this question we have just changed the equation, that's it. Okay, because in the last question we did not have k, so there was a little confusion, right? So this term was not there in the last question, right? So that I've taken another example. Okay, so here also first step we will calculate a vector cross b vector. So once we have done that, next step is to calculate the magnitude. Okay, so whenever they give that, to check whether the unit vectors are perpendicular or not, so this is the formula that we will be using, right? Yeah. So once you calculate a vector cross b vector and once you have the magnitude, just substitute in the formula, that's it. Okay, so this is the second assignment question that we have seen. So now we will move on to the second concept in our chapter. Okay, that is vectors. So what do you mean by a vector? What do we mean by a vector? Okay. So vectors are physical quantities that can be completely described by magnitude. Okay. So what is the main difference between the scalar and vector is? The scalar quantity, okay, always we will have only the magnitude for a scalar quantity. Only magnitude we will have. Okay. So, but for a vector, for the vector physical quantity, we will have both magnitude and direction. Okay, magnitude and direction we will have for the vector quantity. Okay, so there is the main difference that we have between scalar and vector. Okay, so vectors are physical quantities that can be described by the magnitude. Okay, so what is the magnitude? So in the problems also we have seen, like I was telling, like we will calculate the magnitude. But what exactly do we mean by the magnitude? So magnitude is a non-negative scalar quantity. Yes. So in the problems also, so this is the the main point for which I have showed you two examples, right? So in both the examples also, we did not get the magnitude value as negative. So it was like 19 square root of 2, right? Yeah, so we did not get any negative. So we did not get it as like negative, value. So magnitude, which is always said to be a positive number. Okay, so a magnitude value will always be positive and along with the unit and direction. Okay, so this is said to be a magnitude. If the dimension of the vector quantity is a pure number, okay, then we will not specify the unit. So for that, for this problem, we will, for this point, we will see one example. Okay, for saying that vector quantity is a pure number, so we will not specify any unit. For example, when we consider this case, this example, so they have given vector v is equal to 1, 3, right? So this, they're telling that this is not a unit vector. So why they are telling that it is not a unit vector? Because its magnitude is not equal to 1, right? So in the problem we have seen like how will we calculate the magnitude. So suppose if we take this value as x and this as y. So how will we calculate the magnitude? It is square root of x square plus y square, right? So this is nothing but a vector v. Okay, sorry, magnitude of v. Okay, this is the formula we will be using in order to calculate the magnitude of a particular vector. Okay, so how will we know that a vector is a unit vector or not a unit vector? So we will only judge that by using this formula. Okay, so once you substitute these values in uh, the formula, we will know that the value of the magnitude of v is not equal to 1, which means that this is not a unit vector. Okay, suppose here if we have vector of 0, 3, okay, then also it is not a unit vector because 3 square will be 9, so it is not equal to 1. Suppose in case we have 0, 1, okay, then this is said to be a unit vector. Okay, understand this 0 square plus 1 square, that is 1. Okay, so then it is said to be a unit vector, right? Yes. So now how will we represent the vectors? So till now we have seen what is a vector, how can we represent the vector, and how we say that a particular vector is a unit vector, right? Yes. So now we will see how we will represent the vectors. Okay, so to represent the vectors, there are two things, by two ways we can represent the vectors, that is by geometrically or graphically, right? So when we represent the vector in the form of a geometric or graphically, we need to specify both magnitude and direction. So yes, this is the main point that I mentioned, right? So in the scalar quantity, we'll have only the magnitude, but in vector, we will have both magnitude and direction, right? Yes. So whenever you represent a vector, you either geometrically or graphically, you will need to specify both magnitude and also its direction. Okay. Yes. A vector is represented by an arrow mark. Yes, you can see here. Vectors will always be represented by an arrow mark, right? Yes. With the arrow head. Yes. Right? Yeah. So the length of the arrow will represent the magnitude of the vector quantity. So whatever this length, okay, so this will represent the magnitude of a particular vector. Okay, the length of a particular vector quantity will always represent its magnitude. Okay, so this is how we will represent the vectors, in the form of graphically, or it can be geometrically, we can represent. Okay, yes. So now we will see another important assignment question for today. Yes, yeah. So yeah, in the last question, so this was the last question we have seen. So now we will move on to the second question, right? For any two vectors, that is u vector and v vector. Okay, show that. So we need to prove this. Okay, we need to prove this. So u vector into v vector the whole square minus u vector cross v vector into v vector. Okay, dot u vector is equal to u square dot v square. So first we will consider, okay, the left hand side, and we will prove that it is equal to the RHS, and we will consider RHS in the next case, and we will prove that it is equal to the LHS. Okay, so this is how we will be solving this question. Okay, I repeat, here in the question they have given two vectors u and v vector, and they have given a equation to us. Okay, so first we will need to consider any one part of the equation, either RHS or LHS. So first, if we are considering LHS, we will prove that LHS is equal to RHS. In the second case, we need to prove that RHS is equal to LHS, right? And then only we say that u vector and v vector are equal. Okay, yes, we will move on to the solution part now. Yes, so given two vectors u vector and v vector, so these are the two vectors that have been given to us in the question, right? Yes, so we are considering that the angle between these vectors would be theta. Okay, so the angle that we have between these two vectors, so let us consider it to be theta. Okay, so to prove, I said we will consider the LHS and we will prove that it is equal to RHS. Okay, and vice versa for the next case. So first we will consider this equation, right? Yes, so u vector into v vector the whole square plus u vector cross v vector whole square is equal to magnitude of those both vectors, right? So first, in order to prove that the LHS is equal to RHS, first we need to calculate the dot product. Okay, so how we are going to calculate the dot product? So this is the particular equation or formula used to calculate the dot product of a particular vector. Okay, so this formula where we can calculate the dot product. Okay, so once we have this formula, so now to simplify and to get the answer, we will be squaring on both the sides. Okay, so how will we square? U vector square into v vector square, that is u vector into v vector the whole square. Okay, this square we have made, okay, is equal to magnitude of u vector square into magnitude of v vector square cos square theta. Okay, so just we are squaring on both the sides. Okay, yes, so this is the equation 1 that we have got. Okay, so now how will we calculate the cross product? Okay, so here we have calculated the dot product by using this formula. Okay, so now how can we calculate the cross product? Again by using this formula. Okay, so how will we calculate the cross product? Is nothing but we will use just this formula and we will calculate the cross product of any vector. Okay, so here again there is a formula we have. So what is the n vector here? It is nothing but the unit vector, right? So as I said, what do you mean by your unit vector? The vector which has value equal to 1. Okay, that is a unit vector. So till now we have followed only 2 steps. So in the first step we have calculated the dot product. In the second step we have calculated the cross product. Okay, so next, so this is the cross product formula that we have. So same way how we have done the squaring on both the sides for the dot product, the same way we will follow it for the cross product formula also. So in the next step we will square on both the sides. Okay, so squaring on both the sides, so u vector cross v vector. So u cross v vector the whole square. Yes, yeah, is equal to square this also. Magnitude of u cross u vector square into magnitude of v vector square into sine square theta. Okay. Yes, we have got this. Just we are squaring on both the sides, right? Yes. So here we have first equation. Okay. Yes. So after we square on both the sides, this is our first equation, right? Yes. So when we square the cross product, this is our second equation, right? So we will add both the equations. Okay. That is u vector into v vector, the whole square is equal to magnitude of u square, magnitude of v square, cos square theta. So this is the first equation and this is our second equation. Just we will add both the equations. Okay. So what do we get when we add both the equations? So this is the resulting equation when we add those both equations. Okay. So here we have cos square theta in equation 1 and here we have sine square theta in equation 2. So when we add both, okay, so when we add both sine square theta, okay, plus cos square theta, so this formula would be equal to 1. Okay, so there is a very important formula that we need to remember for solving any kind of this kind of questions, right? So sine square theta plus cos square theta will always be equal to 1. So this will tend to 1. Okay, so what we have here, u vector dot v vector the whole square plus u vector cross v vector the whole square is equal to magnitude of this. Okay, so hence by considering the LHS we have proved that the equation is equal to RHS. I'll show you the question now. Yes, so here we have taken this part and we have showed that it is equal to the RHS, right? So next case we will do vice versa. We will take RHS and we will show that we will prove that it is equal to the LHS part, right? Yes. So in this case, we will consider the right hand side of the equation. Okay. This is the equation. So we will consider the right hand side of the equation. Okay. So we will consider this part, right? Yes. So 1 minus u vector into v vector the whole square plus u vector plus v vector plus u vector cross v vector the whole square. This is the magnitude. Okay. So how will we simplify this? This is in the form of a minus b the whole square, right? So what is the formula of a minus b the whole square? Yes. So it is a square plus b square minus 2ab, right? Yes. So it is a square plus b square minus 2ab. Okay. So we will substitute these values in this formula. Okay. Again, this is an important formula that we need to remember. Okay. Yes. So here we will just substitute the values here. Okay. Yes. So 1 minus u vector square into v vector square, that is whole square, plus here the same way, here also u vector plus v vector into u vector into v vector the whole square, that is the magnitude. Okay, so here we have applied this value in this formula. Okay, that is 1, okay, plus which is b square, okay, this whole square, right, minus 2ab, okay, 2ab. Okay, so we have got 2 u vector into v vector, right? Again, plus we will write these terms as it is. Okay, that is u vector plus v vector square plus again it is in the form of, again here we will consider this as a and this as b. Okay, again it is in the form of a plus b the whole square formula we need to apply here, right? So we will be writing as a square plus b square. Okay, b square is this whole square plus 2 into ab, u vector into b vector. Okay, plus 2 we will just cross multiply here. So 2 into u vector, 2 into v vector, plus when we consider 2 into v vector, again u vector cross v vector. Okay, so this is just we will apply in the form. Okay, so now they have given a special note here. What is that? U vector dot u vector into v vector, and v vector dot u vector into cross v vector. So this will be both. So these two terms will be both equal to 0. So why they are equal to 0? As u vector and v vector are perpendicular to each other, right? They both are perpendicular. So we will be left out only with this particular equation, that is 1 plus, we will just rearrange the terms here. Okay, that is u vector into v vector the whole square plus u square plus v square. So here minus 2 and plus 2 will get cancelled. So u cross v the whole square. We have got this equation. So just now we will rearrange the terms, right? So when we rearrange the terms, it is 1 plus u vector square plus v vector square plus this, okay, u vector into v vector the whole square plus u vector cross v vector the whole square, right? Yes. So what is this u vector into v vector the whole square plus u vector cross v vector the whole square? This is nothing but which will tend to u vector, the magnitude of u vector square into magnitude of v vector square. Okay, this is a formula that again we need to remember, right? Yes, so there is a formula. So depending on this formula, we have written this value here. Okay, yes, so now magnitude of this will be equal to 1. Okay, so we will be left out with 1 this term. Okay, so 1 plus u square into 1 plus v vector square. So hence we have proved that the RHS is equal to LHS. Okay, so this is how we have solved this problem. Okay, yes. So now we will see another concept in the chapter. Okay, yes. So this is a vector representation we have seen. So now we need to see about the equality of two vectors. Okay, yes. So when do we say that two vectors are equal? If they have same magnitude and direction. So why we are considering both magnitude and direction here? Because it is a vector, right? So if it is a scalar, then we will have only the magnitude. But since it is a vector, so it should have same magnitude and same direction. Then only it is said to be a equal vector. Okay. So we say that the two vectors are equal only when it has same magnitude and same direction. Okay. Yes. So when you apply some force on a rigid body, okay, so suppose if I have a block, okay, so I am pushing the block like this. So what does I am doing? So I am pushing the block. That means I am giving a force to that block, right? So when I am giving force to that block, I can give force at any point on the block, right? Yes, it will move. If I give force on the this particular end of the block, it will move. If I give force on this particular end of the block, it will again move, right? So that when I give force on in the rigid body, maybe to any point on the body of the surface. When do we say that the two vectors are said to be equal? Yes. Vector, we will be considering both magnitude and direction. Okay, yes. So we say that two vectors are equal only if they have same magnitude and direction. Then only those two vectors are said to be equal. Okay, yes. So the force exerted on the rigid body, as I said, when I give force on any end of the block will move. Okay, when I give force on the block, it moves, right? That means I am exerting a force on the block, right? Yes. So if you give force to a rigid body at any point on the surface, it will move, right? Yes. So in such cases, two vectors are said to be equal if they have the same magnitude and direction and also the same line of action. Okay, so what do you mean by same line of action here? Yes, so once we are moving the block, okay, yeah, at what particular direction it is moving, at which particular line it is moving. Okay, so in that case we will consider the same line of action also here. Okay, so when we are considering the vector with magnitude, with direction, and also the same line of action, then we call such vector to be the sliding vectors. Okay, yes. So now before we move on to the unit vector, so we will see one assignment problem. Okay, yes, we have seen this question. So we will move on to the next question. Yes. So this is the next assignment question that we have. Ravindra, is it visible now? The assignment question?
Yes, ma'am.
Okay. So solve the following ordinary differential equation. So what do you mean by differential equation? So it would be in the form of dy by dx, right? Yes. So always the differential equations would be of this form. Okay. Yes. So we will see the question. So this is the question that we will be solving for today. Okay. So d square y by dx square plus 2 dy by dx plus 2y is equal to 0. So this is the first equation that we have. Okay. So these are the two conditions that have been given to us. Okay. So y of 0, the value would be 2, and y dash of 0, the value would be 1. Okay, I hope you understood the question. They have given a particular equation and they have given two particular conditions for us. So when we get these values like y of 0 and y dash of 0, when we solve this equation, so we need to substitute these values and get the final answer. Okay, we will see how it can be done. Yes, so this was the equation that has been given to us. Okay, yes, so dx plus dy is equal to x plus y into dx minus dy. Okay, so how can we write this? So we will just move x plus y term towards the other side. Okay, so x plus y towards other side, when we move it becomes minus, right? So minus of x plus y dx is equal to minus of x plus y dy. Okay, so here when we move this term to this side, it would be negative, right? Yes, so here just to this equation I'll just add minus 1 and plus 1 for my simplification. Okay, so minus 1, adding minus 1 plus 1 doesn't make any difference here, right? We can also cancel it, right? But why am I adding? It is for my simplification. That is for the further steps. If we need to simplify and get the answer, we would be doing this. So add just minus 1 and plus 1 on both the sides. Okay. So now you will just bring this to the denominator. So dy by dx. Okay. So that is minus and minus you will cancel here. Okay, so x plus y minus 1 divided by this will come this side, that is x plus y plus 1. Okay, this is the first equation that we will get when we solve dy by dx. Okay, yes, so now when we have got this x plus y minus 1, x plus y plus 1, so we will substitute x plus y as v. Okay, yes, that is the next step. We will substitute x plus y is equal to v. Okay, so how the equation would be then? That is 1 plus, here instead of x plus y we will substitute it as v. Okay, so when we substitute it as v, that is dv by dx. So how will we represent the v in the form of differential equation? That would be dv by dx. So in this form only we will represent v. Okay, so 1 plus dy by dx is equal to dv by dx. Okay, yes, so now when we move this dv by dx, so when we move 1 to the other side, it would be minus 1, right? So minus 1 is equal to, here we have x plus y minus 1, x plus y plus 1. So x plus y we are substituting it as v. So v minus 1 divided by v plus 1. Okay, so dv by dx would be v plus v. That would be 2v divided by v plus 1. Okay, yes. So this is the final answer that we get. So here we are just doing the cross multiplication. So v plus 1 into dv, okay, will be equal to dx. So this comes to the denominator. Just cross multiply. Okay, so this is the equation we have got after we have cross multiply. Okay, so now we will perform the integration process. Okay, so in any differential equation we will perform the integration process at the last step in order to get the answer. Okay, so for this equation, that is v plus 1 divided by 2v. So v plus 1 divided by 2v is equal to integration of dx. So how will you integrate? For the given equation, you will write integration on both the sides of the equation. So this is how we will integrate, right? Yes. So here v, in which we will take 1 by 2 as common. Okay, then it is v plus log v. Okay, so 1 divided by v is nothing but log v. Okay, this 1 divided by v, we can write it as log v is equal to, here we have dx. So integration of dx is x plus c. Okay, there is a formula again we need to remember. Okay, so here again we are back substituting. So we know what is back substitution, right? So in the first case we have taken x plus y is equal to v. So now we are just back substituting. Again here we will substitute v as x plus y. Okay, so x plus y plus log of, so v x plus y, okay, is equal to 2x plus c. How did we get 2 here? We have just cross multiply. So from the denominator, we have taken it to the numerator. So 2x plus the constant c. Okay. So y plus log of x plus y. So when you bring x to this side, it would be minus x, right? Yes. So 2x minus x is nothing but x plus c. Okay. So this is the final equation that we are getting when we solve that particular question. Okay. Yes. So for any differential equation, if they give you, we need to just substitute, take x plus y as v, okay, and then we will perform the integration process and you will back substitute. Okay, so yeah, this question is all about integration. So now again we will move on to the concept. Yes, so we were seeing about the unit vector. Yes, so as I've told you, like what is a unit vector? It can have a magnitude as 1. Okay, it can have a length or the magnitude as 1. That is called as the unit vector. Okay, unit vector where always the magnitude would be equal to 1. Okay, unit vectors are taken to be dimensionless. Okay, so you will not have any dimensions to the unit vector. Okay, you will have only the magnitude. You will not even have the direction. You will not even have the dimension for it. Okay, you will have only the magnitude. A unit vector is used to denote the direction in space. Yes, so only in space it will be used to denote the direction. Otherwise, it is only the magnitude for a unit vector. Okay, so how will you represent a unit vector?